Assalamualaikum guys. Today we are going to do the revision, the Unit 5 energetics. Right. So we have done the question number 1 and 2. So I am going to discuss those questions here. Let's move on to the first question. Question number 1. Consider the reaction, right? Your CH4 gas will give you the CH3 gas plus hydrogen gas. The standard change in enthalpy of above reaction is. Once you look, you are able to find what kind of the reaction is this. This is very easiest question. Quickly you can find the answer. Let's see more. How to find the answer. Yes. Then you can see here methane is becoming as a CH3 gas and this is hydrogen gas. So usually this is what is the bond of the CH4. Right. Then how it's coming is coming as CH3 plus hydrogen. So what should be this? Or were in gaseous state. What could be the answer? Let's take the standard enthalpy change. You are going to find what is this reaction. The standard enthalpy for this reaction. What type of this? The standard change in enthalpy above reaction could be. The standard enthalpy change for dissociation of the first CH bond. Can you see? The word is clearly mentioned. The dissociation of the first CH. Yes. What happens here? One bond, one hydrogen, one bond has dissociated, the hydrogen becoming as an individual one, right? So this is what they said, the dissociation of the first CH bond in the. Obviously, that should be the answer. Okay, so we will mark this is as an answer, but let's check the next one. The standard atomization enthalpy change of the methane. So what is mean by atomization? Yes, any molecule should become full breakdown. Fully it should be breakdown and becoming as what? Just individual gases. So when you take, right, this is here. When you take the CH4 gas, the full atomization, what should be there? It should become as this for hydrogen gas. So this is what called the atomization reaction, and here not now. So that is not. So what is wrong? The first ionization energy, what is mean by that? It's leaving, yeah, it's able to donate the electron. So that is also not possible. And standard bond dissociation enthalpy change of the methane. This is very important. What is the difference of the enthalpy change for the dissociation of the first CH bond and just a bond dissociation? Simply that is also seems to be like what? Your atomization, right? So that is also wrong. Standard radical formation of the enthalpy. So there should be radical. Ultimately, initially you will come, yes, the CH4 when it's clipped, you will end up like this, right? So not this also. So these all answers are wrong. So your answer is number 1. Let's move on to the next question. This is true false statement question. This usually you will get in your past paper for question number 41 to 50, right? So let's find, right, which one is the true false question. The first statement is a reaction occurring spontaneously in an isolated system. Always the word is very important. One is the isolated system, another one is always negative its energy. So ultimately, yes, if it is spontaneous reaction, you can say that should be negative in Gibbs free energy. That should be the answer. But isolated system, what is mean by the isolated system? Neither energy of heat not pass from your system, this is your system, and this is your surrounding. So this means what? Your energy is constant here. Not never. Energy is constant. Though your energy is constant, what would be happen? The entropy always can be positive. That means it able to increase or it should be constant. It never can't be negative. So when you speak about the spontaneity, you should be able to go for this reaction. Delta G is equals to, yes, delta H minus P delta S. If you need this is as a negative, why? This is what should be able to carry. So that is also not. Yes? So what about the temperature and the enthalpy? That is also you can't keep as what? Constant. If you can't keep this is as a constant, how can you say this should be what? Negative sign as for the spontaneous reaction. Though this is what is also minus, okay, positive. The negative charge is increasing. Why can't be the temperature also can be increased? As it is what? It's not absorbing from the surrounding to maintain the constant, right? So what is happening inside the system? The entropy is high, therefore the temperature may be increased. The enthalpy heat evaluation will be increased. So you can't say. So sometimes the molecule will absorb. So it can be decreased. So we can assume that is also can be kept as a constant. So that's why this statement is false statement. The first statement is false. And let's now move on to the second statement. A process in an isolated system cannot be changed from outside. Yes, I said. What is meant by the isolated system? Yes. Neither energy or heat could not be transferred or exchanged in between the system and the surrounding. So that what they said, the process in the isolate cannot be changed from the outside. Yes, that is absolutely true. So your answer is false true. That should be, what is the combination? Answer number 4. Right. Okay. I'll give you some more time to find the next question. Just read the question very calmly and let's read it. The first two question really little bit easy, that's why I just done it. Okay, let's move on. Let's move on to the question. A reaction is spontaneous at 298 Kelvin and 100 kilopascal pressure, while it is non-spontaneous. Give me a second. Yes. While it is non-spontaneous at high temperature. It is non-spontaneous at high temperature. So that should be spontaneous only this normal temperature with higher kilopascal. So and the same pressure. So which following is true for this reaction? 298 Kelvin, 100 kilopascal pressure. So this is very important. When you speak about the spontaneity, first you are able to write this reaction. Delta G is equal to, yes, delta H minus T delta S. Right. So definitely we are talking about what? The spontaneous of the reaction. If it is spontaneous, what should be there? The delta G should be negative sign. So the delta G negative sign means what? It should be less than, should be negative, and that simply you can say delta G should be less than C. So from this you can say when they mention as the delta G as a positive, we can omit the answer. This is as a positive, this is as a positive. So answer number 1 and 5 simply you can omit. Now, next we move on to the next step. So you can observe the delta S now. So we are talking about the delta S is what? So entropy. So though you need the delta G is as a negative, your entropy should be what? Yes, highly negative. Then it could be positive. So when you speak about the highly positive. So when you say this is as a delta S as a highly positive, then only it can be what? This whole system can become negative. But they say at high temperature, this is non-spontaneous reaction. When the temperature, this the entropy combined together according to your information, right? Your delta S T should cause us highly negative. But they say at what high temperature, so therefore your temperature should be high. So that is also not possible. Why? At high temperature it's becoming what? Non-spontaneous, the reaction becoming upon non-spontaneous. So you could not speak about the highest temperature, then only it is able to process the highly negative. So you can't say the delta S as a positive. So you can check here 1 and 5 already omitted. Now you have 2, 3, 4. Out of 2, 3, 4, here you have delta S is positive. So you can omit the third answer also. Now it's simply clear. You can find either true. So according to the statement, right, it's, the reaction at the normal condition, the delta G should be negative sign, and about your information, the delta also S also should be negative, it could not be positive. Next, you know this equation. Now you can say the delta S should be negative. Then only this reaction can force us toward the spontaneous. Why? This is a normal temperature, this is also negative, so let's see right. Okay, so now you know your delta G is negative. your delta S is there. Now you